Yeah, hello, we're back again and we continue from where we stopped last time. We last spoke about a hyperbola. Today we're going to talk about a parabola and definitely conclude this functions topic. Let's just talk about a parabola. So a parabola can actually be written in three different ways. One where you could just write it as y is equal to a outside x plus p plus q, or way one you can just write it as ax squared plus bx plus c, or the last one. So these are three ways you can actually write a parabola. Y is equal to a x minus x1 x minus x2 x2. So this is just it. This is how you could forgot something up there. Squared. So this is how parabola can actually be written down. Now, just like we did with the hyperbola, let's just talk about the general outlook of a parabola. If a is less than 0, which means that a is negative, then you expect it to be something like this, looking down. Other people are saying it's a set face. My shape is very bad. Yeah, still very bad. But sure, it could be something like this. When a is positive, then something like that. This is how a parabola would generally look. Sure. And so you can see there's definitely a turn somewhere here. So we can talk about a turning point of a parabola. If you want to find the turning point of a parabola, say you're given this first method, sure, not this first way of writing it down. What we will do is just say x plus p is equal to 0. So that means x is equal to minus p. That is your x value for your turning point. And it's probably the same thing we did when we wanted an asymptote the other side. I'm not saying this is an asymptote, but this is the same thing we did when we wanted an asymptote for the hyperbola. So sure, this is what you'll do. So that means your turning point will be minus p q. So that becomes a turning point. Or if you've got the other two methods, the straight away thing to do is to say x is equal to minus b over 2a. Find that to be your x value. Then you take f of minus b over 2a. Then this will be your y value. So what this means is whatever value you get here, plug it in your original function. Then you'll be able to find the exact value that we're looking for. Also, we need to talk about something else here. Once you have a turning point, you'll also have one other thing, the axis of symmetry. So the axis of symmetry is, say this is your graph and this is your turning point. This line that cuts your graph into half becomes your axis of symmetry. So it means just here it's going to be x minus p, or the equation of axis of symmetry will be just minus b over 2a, depending on whichever method that you are using or which way you are actually using. So that's just it. Now, just general things that you'll be expected to do. You'll be expected to do in this this part is being able to solve for x, right? Especially when you're looking for x-intercepts. So it's in the form of a x squared plus b x plus c equals 0. If you ask to solve for x here, that's just the general question one standard. You just use that. You have to make sure that this is in the standard form, factorize and find the solution. If say you can't factorize a this has always been my go-to thing, minus b squared minus 4ac. Use a quadratic formula. You'll never go wrong. As long as you've written this in a standard form and it's correct, then you can use that. Else, we can talk about what does this actually tell you about the graph. So when a is positive, this tells you that it has a certain maximum. So this is the maximum, right? And it's at minimum when this is positive. So negative, it's at maximum, then it's at minimum. It has a minimum value and it has a maximum value. That's what I'm trying to say. But sure, guess it didn't didn't skip anything about a parabola. Also, what else? Let me try to think of something that I might have skipped. Sure, domain and range. Yeah, your domain is just one thing every time for a parabola, as long as you're not restricted. Your domain is just x element of the reals. That's just it. But your range always depends on one thing: are we at maximum or are we at minimum, right? So if we are at if a is greater than 0, then we know that we have a minimum value. Therefore, y is always greater or equal to your minimum value. In this case, if our turning point is negative p, q, and this is our this is our y turning point, then this becomes our minimum. So it will be just q, just like that. Else, if we have a maximum value, then y is just less or equal to q again, which is the maximum value. This just represents y value over turning point. That's just it. I don't think there's anything that is much more interesting about the parabola. Let's see if we take a question. Well, let's reserve that for another video, but that's just it about the parabola. Okay, it looks like we still have a few seconds. We can squeeze in something. What we're going to squeeze in here is, now what happens if you're taking say certain translations. So let's talk about that, translations. Before we conclude this video, I would like us to just touch a bit on translations. Now, translations here, we're talking about you reflecting, you shifting, all of those things. If you shift your function about the y-axis, this would mean one thing. If you had a coordinate x, y, this type of a shift or a type of a reflection, in fact it's not a shift, you reflect. Shifting is when you're moving it to the left, the right, up, down. That's shifting. But this is a reflection about the y-axis. To be specific, what happens is, if it's about the y-axis, then your new coordinate is something like this. This is something that we did in grade 9, right? Yeah. And then a reflection about the x-axis. Again, this, you have your x, y. This becomes x minus y. Let's take a quick example. You have f of x is equal to 2x minus 3 squared plus q. You can, let's have a value for q3. If you want to reflect this graph about the x-axis, this will need to be specific. If you're reflecting it about the x-axis, then your new graph becomes minus y is equal to 2. So to solve this becomes y is equal to, you divide by negative 2. No, you don't divide by negative 2. You divide by negative. So you'd have negative 2 x minus 3 squared plus, in fact this also becomes negative because you divide throughout by that negative. Now if you are reflecting this about the y-axis this time around, the first one was about the x-axis, now about the y-axis. So this becomes y is equal to 2. You just put a negative before your x minus 3 squared plus 3. So that's just it. You've managed to actually address these reflections. I think this is a good point to stop. We'll actually talk about other translations which are like shifting and stuff like that, and one special one where you reflect about the line y is equal to x. That's where we start talking about inverses.